There is a lie that has been told to you about science. It is a lie that keeps you feeling small. It is a lie that keeps you on the sidelines. The lie is this: to do real physics, you need $1 billion laboratory. You need to be in Switzerland, hundreds of feet underground at the Large Hadron Collider. You need to be in a frozen basement at Google or IBM wearing a white hazmat suit, looking at a golden chandelier hanging from the ceiling. You need a PhD from MIT. You need clearance. You need permission. They tell you that quantum physics is a spectator sport. They tell you that you can watch the documentaries, you can read the books, you can listen to the podcasts, but you cannot touch. They are wrong. Right now, sitting in front of you is a portal. Your laptop, your smartphone, that device you use to watch cat videos and scroll through social media, has the power to connect directly to the fabric of the universe. You do not need a labs, you do not need a degree, you do not need a single dollar. You can simulate a quantum system in your bedroom tonight. And more than that, you can actually run code on a real, physical quantum computer sitting in a freezer in New York from your couch in London or Mumbai or Tokyo. We are living in a historic moment. The barrier to entry has collapsed. The gods have handed down the fire and they have put it on the cloud. If you are tired of just hearing about superposition and entanglement and you are ready to actually create it, if you are ready to stop being a fan of science and start being a scientist, please hit that subscribe button right now. Because today, we are going to turn your computer into a quantum machine. Let's start with the philosophy of what we are about to do. Richard Feynman, one of the greatest physicists who ever lived, once said something that changed the world. He said, "Nature isn't classical, damn it, and if you want to make a simulation of nature, you'd better make it quantum mechanical." What did he mean? He meant that your standard computer, the one you are using right now, is a liar. It thinks in ones and zeros, it thinks in black and white, it thinks in yes and no. But nature doesn't think like that. Nature thinks in maybes. Nature thinks in clouds of probability. When you play a video game and you see water flowing or smoke rising, your computer is faking it. It is doing a very hard calculation to approximate the look of the water. It is struggling. To truly simulate the universe, you need a computer that works like the universe. So how do we do that at home? We have two options. Option 1, the simulator. This is where we teach your classical laptop to pretend to be a quantum computer. We force it to do the heavy math to predict what a quantum computer would do. This works great for small systems. Option 2, the cloud. This is where we write the code on your laptop, send it over the internet to a facility where a real quantum computer lives, run the experiment on actual atoms, and send the results back to you. We are going to do both. And the tool we are going to use is a language you might already know, or one you can learn in an afternoon. Python. Python is the language of the new quantum revolution, specifically a library called Qiskit. Qiskit was developed by IBM, it is open source, it is free, and it is the spellbook. I want you to visualize this. When you write a line of code in Qiskit, you are not just manipulating numbers on a screen. You are composing music for atoms. You are telling a microwave pulse to hit a specific electron at a specific frequency to rotate it into a state of superposition. So step 1 in your journey is to get the tools. You need to install Python, you need to install Qiskit. There are 1,000 tutorials on how to do this technically, so I won't bore you with the installation process. I want to focus on the experience. I want to focus on what you are actually doing to the fabric of reality. Let's imagine you have your environment set up. You open a blank script, the cursor is blinking. You are about to write your first quantum program. In the coding world, the first program you write is usually "Hello World." It just prints text to the screen. In the quantum world, our "Hello World" is something much more profound. It is called the Bell state. This is the creation of quantum entanglement. You are going to write code that takes two separate qubits, two separate digital entities, and fuses their destinies together so that they become one. Here is how you visualize it as you type. First, you declare your registers. You say, "Computer, give me two quantum bits." Let's call them qubit 0 and qubit 1. Right now, they are boring. They are both sitting at 0. They are just like normal computer bits. Now you apply the first spell, the Hadamard gate. In your code, it looks like H0. What does this do? Imagine qubit 0 is a coin sitting on the table showing heads. The Hadamard gate reaches out and flicks the coin. Now the coin is spinning in the air. It is a blur. It is heads and tails at the same time. You have just created a superposition on your laptop. You have taken a definite piece of information and dissolved it into a wave of probability. Now you apply the second spell, the CNOT gate controlled knot. In code, it looks like CX01. This is the entanglement gate. This is the magic. This gate tells qubit 1, look at qubit 0. If qubit 0 is spinning, you spin too. If qubit 0 stops, you stop. Whatever state qubit 0 chooses, you react to it. Because qubit 0 is currently in a superposition spinning, qubit 1 enters a superposition too. But they are now linked. You have created a Bell state. If you measure qubit 0 and it lands on heads, qubit 1 will instantly land on heads. If qubit 0 lands on tails, qubit 1 lands on tails. You have just simulated the phenomenon that Einstein called spooky action at a distance. Now you hit run. If you are using the simulator, your local laptop, your CPU starts sweating. It has to calculate the complex matrices and probabilities of these wave functions. It spits out a result, a histogram. It shows you a bar chart. 50% of the time, 0 both heads. 50% of the time, 11 both tails. 0% of the time, 1 or 10. It proves they are entangled. They never disagree. This moment, looking at that bar chart, is a spiritual experience for a geek. You have just confirmed the fundamental weirdness of the universe using free software in your bedroom. But wait, that was just a simulation. That was your laptop doing math. What if you want to touch the real thing? This is where it gets crazy. IBM and others have connected their actual physical quantum computers to the cloud. You can create an account, you get an API token. It is like a VIP pass to the future. In your code, you change one line. Instead of backend equals simulator, you write backend equals implied, or whatever the name of the real computer is. You hit run. Your code travels over the internet. It goes to a facility. It enters a dilution refrigerator that is colder than deep space. Inside that fridge, there is a chip. On that chip, there are real superconducting circuits acting as qubits. Your code sends microwave pulses down the wires. It physically manipulates those circuits. It puts them in superposition. It entangles them. And then it measures them. The data comes back to your laptop. But this time, the graph looks different. On the simulator, it was perfect, 50-50. On the real machine, it is messy. Maybe it is 48% 0 and 49% 11, and maybe there is a tiny 3% of 1. Why? Because of noise. Because the real world is noisy. Because heat or a stray magnetic field or cosmic rays interfered with your qubits. This is called decoherence. And seeing that error is actually the most beautiful part, because it proves you touched reality. You touched the fragile, shaky, imperfect nature of the quantum world. You struggled against the same forces that the best physicists in the world are fighting. You are now a quantum engineer. So what else can you do? What projects can you build at home? You can't crack bank passwords yet. You can't simulate a whole human brain. But you can do things that feel like magic. Let's talk about project number 2, quantum teleportation. Yes, you can simulate teleportation at home. The protocol is real. It uses 3 qubits. You have Alice qubit 0 and Bob qubit 2, and you have the message qubit 1. You want to move the state of the message to Bob without moving the particle itself. You can write a script that entangles Alice and Bob, then Alice interacts with the message, then Alice measures her qubits. Then, and this is the key, you use classical code, if statements, to tell Bob what to do based on Alice's measurement. If you run this, you will see the state of qubit 1 disappear and reappear on qubit 2. You have just moved information without traversing the space in between. Simulating this teaches you something profound about the universe. Information is physical, and information can be fluid. What about something more practical? Project number 3, the true random number generator. Computers are bad at being random. If you ask your laptop for a random number, it uses an algorithm. It uses the time of day or the mouse position to fake randomness. If you knew the algorithm, you could predict the number. It is pseudo-random. But a quantum computer is truly random. Remember the sewer position? When you measure it, nature rolls the dice. God plays dice. You can write a simple script, put a qubit in sewer position, measure it. If it is 0, print heads. If it is 1, print tails. If you run this on a real quantum computer via the cloud, you have created the only source of true, unpredictable randomness available to humanity. You can use this to generate passwords. You can use it to make decisions. Should I order pizza or burgers? Let the quantum universe decide. It is the ultimate coin flip. Now let's talk about the barrier. Why isn't everyone doing this? Because it requires a new way of thinking. Classical programming is about logic, if this then that. Quantum programming is about interference. It is about geometry. You have to visualize the qubits not as switches, but as arrows pointing inside a sphere. We call it the block sphere. When you apply a gate, you are rotating the arrow. When you entangle them, you are dancing with multiple spheres at once. It is hard, it breaks your brain. But that is why you should do it. We are entering the quantum era. In 10 or 20 years, quantum computing will be where AI is today. It will be everywhere. It will be designing our medicines. It will be optimizing our traffic. It will be cracking our encryptions. The people who understand it now asterisk are the ones who will build that future. You don't want to be the person who looked at the internet in 1990 and said, "That looks complicated." You want to be the person who built the website. You can start exploring quantum machine learning. This is the cutting edge, using quantum systems to train AI. There are libraries for this now. You can take a data set, say pictures of cats and dogs, and try to classify them using a quantum circuit. It is rudimentary right now. It is like the early days of video games, Pong, Space Invaders. But you are playing Pong on a machine that operates on the laws of the multiverse. Let's go back to the idea of simulation. Why is this so emotionally powerful? Because when you simulate a quantum system on your computer, you are essentially mimicking the operating system of reality. There is a theory called the simulation hypothesis. It says that our entire universe might be a computer simulation run by a higher intelligence. When you write Qiskit code, you start to see why people believe that. You see that matter is just data. You see that energy is just relationships between variables. You see that measurement is just rendering the output. By building a mini-universe in your laptop, you start to feel a kinship with the architect of the real universe. You start to see the code behind the curtain. So how do you start today? You don't need to buy a textbook. Go to the IBM Quantum Learning platform. Go to YouTube tutorials. Look for Qiskit textbook. It is interactive. It is gamified. Start with the visualizer. Before you write codes, you can use a drag-and-drop interface. You can drag a Hadamard gate onto a line like a musical note. You can drag a measurement block. You can see the sphere rotate in real time. It makes the abstract concrete. Then once you see the visual, look at the code it generates. QCH 0. QC measure 0, 0. It connects the visual to the syntax. Then try to break it. Create a circuit that makes no sense. Add 100 gates, see what happens. That is how you learn, you play. We are conditioned to think that physics is serious. We are conditioned to think that experiments must be peer-reviewed. But the best experiments are the ones you do for yourself. The experiment where you try to make 3 qubits agree on a color. The experiment where you try to send a secret message to yourself using teleportation. These are the experiments that change who you are. They change you from a consumer of reality to a student of reality, and eventually a master of reality. I want to leave you with a challenge. Do not just watch this video and nod your head. Do not just say, "Wow, that sounds cool," and then click on a video about cats. Open a new tab, search for IBM Quantum Experience, sign up. It is free. Drag 1 gate onto the line. Hit run. And realize that somewhere in the world, in a dark, cold room, a tiny pulse of energy just obeyed your command. You reached out your hand and touched the quantum realm. And once you touch it, you will never look at your solid, boring, classical world the same way again. You will see the waves, you will see the possibilities. You will realize that the computer in your bedroom is a magic wand. You just have to learn the incantations. If this guide to becoming a bedroom quantum physicist sparked a fire in your mind, if it made you feel powerful, please hit that like button. It helps the algorithm find more potential wizards. And share this with a friend who loves coding or a friend who loves space. Tell them we can build a universe tonight. Hit subscribe. We are going to keep unlocking the secrets of the cosmos, one line of code at a time. Let me know in the comments, what is the first thing you would do if you had a powerful quantum computer? Would you cure a disease, or would you just create a really good random number generator? I'll see you in the cloud. Stay entangled.